Welcome back to our Python Basics series. Today, we're talking about operators. Now, there's going to be a decent amount of stuff we go through, so as always, check the description down below for additional practice. With that being said, let's take a look. All right, let's start by looking at operators. Operators are used to perform operations on variables and values. We use operators to create expressions. The operators are special symbols that designate that some sort of computation should be performed. The values this operator acts on are called operands. And that brings us to expressions, which are the full sequence of operands and operators. Today, we're going to go over some of the operator groups. This isn't all of them, but they're the ones that you'll find most useful. Starting out with arithmetic operators, these are used with numeric values to perform common mathematical operations. We've already learned some of these. We are able to use addition, subtraction, multiplication, division, modulus, exponentiation, and floor division. We can start with an example of the most basic ones, the addition, subtraction, multiplication, and division. Let's start by creating two variables, x and y, and setting them equal to the values 20 and 7. This is something we haven't done before, but what I just did was assign two variables in one line. This is the same thing as saying x equals 20 and y equals 7. This may be a helpful tip for you to know. We can go ahead and remove this portion. Looking at addition first, we can say x plus y, which will give us 27. For subtraction, we can say x minus y. Then for multiplication, we can say x times y. And finally, for division, we can say x divided by y. One option we have is assigning these expressions to variables. Another option we have is just printing them out so we can see what they're equal to. For now, I'm just going to print these out so you can see what it's doing. When I run this code, you can see that it prints out four values. The first one is 27, which was x plus y. So 20 plus 7 is 27. The second one is 13, which was x minus y. 20 minus 7 is 13. The third one is 140, x times y. 20 times 7 is 140. And then the final one is x divided by y, which is approximately 2.9. 20 divided by 7 is 2.9. Now that we've knocked out the basic ones, let's look at modulus, exponentiation, and floor division. We'll come up here and remove these lines. So when you hear modulus, think of remainder. So if we did 20 divided by 7, what would the remainder be? In our specific example, it would be 6 because 7 goes into 20 twice, which gives us 14 total with a remainder of 6. To use modulus, we say x percent y. If we come over here and we print this out, you'll see when we run it, it outputs 6 because that's the remainder of 20 divided by 7. The next one we'll look at is exponentiation. So instead of doing a modulus sign, let's say star star. This is saying 20 raised to the power of 7. If we run this, you'll see that it gives us a big number, which is 20 raised to the power of 7. And then finally, let's look at floor division. Think of floor division as division but rounded down. If we look at our specific example, if we did 20 floor division 7, we know that 20 divided by 7 is approximately 2.9. Instead of returning 2.9, it's going to round that down to 2. So if we come in our code and replace the star star with divided by, that's saying do floor division and it'll print out 2. And as you can see, when we run it, it prints out 2. Next, we'll look at assignment operators. These are used to assign values to variables. For now, let's just go over the basic ones and combine them with the arithmetic operators. The most basic one that we've been using since the variable episode is the equal sign. Just as a reminder, we could create a variable named z and set it equal to 30. This equal sign right here is an operator. Now let's say we wanted to do something a little different. Let's remove this line. Let's say we wanted to set the variable x equal to x plus y. One way of doing that would be saying x equals x plus y. Using these arithmetic operators, we can combine them. We can just say x plus equals y. Now we no longer need this row. If we come down here and we print x, you'll see when we run it, it prints out 27. That's because we're setting x equal to the value of x plus y. X is 20, Y is 7, it equals 27, and it reassigns that to the variable X. The same concept applies to the minus sign. We could say X minus equals Y, which is equal to X equals X minus Y. Now if we run this, you'll see that it prints out 13 because X minus Y is 13 and we set that equal to X. We can also do this with multiplication. This is saying X equals X times Y. Now when we run this, it prints out 140 because X equals X times Y, which is 140. And finally, we can use divided equals. So this is saying X equals X divided by Y. When we run it, you'll see that it gives us 2.9 approximately. As for modulus, exponentiation, and floor division, we can do the exact same thing. We can say X percent equal Y, which gives us 6. 20 modulus 7 is 6. We can say X to the power of Y, which gives us somewhere around 1.2 billion. Or we could do floor division, which is X floor division Y, and that gives us 2. So now that we've looked at arithmetic and assignment operators, let's look at comparison operators. Comparison operators are used to compare two values. So if you remember back to our Boolean data type, these return either a true or a false value. Let's go ahead and remove these lines. We still have X equals 20 and Y equals 7. Using our arithmetic operators, let's say X plus Y. We know that equals 27. Now let's learn our first comparison operator, which is equals equals. And then for now, let's just say 27. So let's break down what this is doing. It's saying X plus Y, which we know is 27. So it's saying 27 equals compare 27. Well, since 27 does equal 27, this will be equal to true. If we come over here, we can print that out. If we run this, you'll see it prints true because 27 equals 27. Now let's look at our next comparison operator, which is not equal to. To do this, instead of saying equal equal, we say exclamation mark equal. So what this expression really says is X plus Y doesn't equal 27. Since we know X is 20 and Y is 7, X plus Y is 27. So really this expression is saying 27 does not equal 27. With that being said, we know that 27 does in fact equal 27, so this is going to print out false. When we run this, you'll see that it says false. For the sake of the next example, let's change the 27 to something like 10. And now we're going to use the greater than operator. What this is saying is X plus Y is greater than 10. X plus Y is 27, so 27 is greater than 10. That's true. When we run it, you can see that it does in fact print out that it's true. Its counterpart is the less than sign. This is saying that X plus Y is less than 10. We know that 27 is not less than 10. This one will return false. When we run it, you'll see that it prints out false. If we replace this with the greater than sign and say equal to, we're saying X plus Y is greater than or equal to 10. 27 is greater than or equal to 10, so it tells us true. Now, if we were to replace 10 with 27, we're saying X plus Y is greater than or equal to 27. This really means is 27 greater than or equal to 27, which it is because it equals 27. As we can see when we run it, it tells us true. Now, if this sign were just greater than, 27 is not greater than 27, it's only equal to 27. So when we run it, it tells us it's false. Which brings us to our final one, which is less than or equal to, which is written as a less than sign and an equal to sign. So this is just saying X plus Y is less than or equal to 27, which is also known as 27 is less than or equal to 27, which we know is true. And when we execute it, it tells us true. Now, if we switch this 27 back to 10, is 27 less than or equal to 10? Well, it's not, so it'll give us false. And as you can see, when we run it, it says false. So moving on, we also have something called logical operators. Logical operators are used to combine conditional statements. Once again, these return a Boolean data type. If you haven't taken a logic class, a concept you should know is truth tables. So we won't spend much time going over truth tables, but I'll include it in the link in the description below. There are 3 of these logical operators that we're going to talk about. The first one is AND. Let's go ahead and remove this line of code. We can combine the comparison operators and the logical operators. For example, we could say x equals 20, which is a comparison. We know that x is equal to 20, so this is true. 20 does equal 20. We can then use the and say y equals 7. So if I was going to say this expression in English, I'm saying, does 20 equal 20 and 7 equal 7? We know that the two expressions x equals 20 and y equals 7 are both true. Since both of these are true, we know that it's going to return true, so let's go ahead and print this out and see what it says. When we run it, you can see that it says true. When we use the and operator, if both statements aren't true, it's going to return false. For example, let's modify the statement and say x not equal to 20. We know this is false because 20 not equal to 20 returns false, even though y equals 7 returns true. A false with a true using an and will return a false. This is seen when we run it and it outputs false. The next one we're going to look at is or. If we came up and replaced and with or, this statement will now return true. With an or, only one of the statements has to be true. So even though x isn't equal to 20 returns false, y does in fact equal 7, which returns true. For that reason, when we run it, you'll see that it outputs true. Now, if we came back in our code and changed this statement so that it's also false, we now have two statements that are both false. When we run this, you'll see that it returns false. Just to demonstrate, we can also set both of these to true statements. This is saying x equals 20 or y equals 7, both of which are true. When we run this, it outputs true. Which brings us to our final one, which is not. What not does is it reverses the result. This means that it will return false if the result is true, but it will return true if the result is false. Using this exact same example, we said x equals 20 or y equals 7. We know that both of these are true and it returned true. If we were to come into our code and add not and then wrap the whole expression with the not statement, we're printing not x equals 20 or y equals 7. X equals 20 is true. Y equals 7 is true. True or true gives us true. And then we're saying not true, which returns false. When we run this, you'll see that it outputs false. This brings us to the last one that we're going to talk about in this episode of the series. This one is a membership operator. Membership operators are used to test if a sequence is present in an object. Let's do an example and just clear our code. We'll create a new variable named x and set it equal to a list. Let's populate this list with some values, 1, 2, 3, 4, and 5. The first one we're going to look at is in. If we come down to a new line, we can select a value that we know is in the list, let's say 4. We can then use the in operator and say in x. What this is doing is it's checking if 4 is in the list x. We can also come down and select a value that we know is not in the list, like 6, and say, is that in x? If we come over here and we print them, it's going to print out two Booleans. When we run this, you'll see it prints out true, false. It prints out true because 4 is in the list, and it prints out false because 6 is not in the list. The other membership operator is not in. To demonstrate this, we can come in our code and we can add not before the in. So what this is saying in line 3 is 4 not in x. Well, 4 is in x, so we know that's going to return false. In line 4, it's saying 6 not in list. Well, 6 is not in our list, so that's going to return true. When we run this, you can see it prints out false and true. With that being said, that's about the absolute basics for operators. I'm going to go ahead and include some helpful links in the description below because I know some of this can be confusing when you're first learning. For now, I would recommend just familiarizing yourself with what's available for you to use and then practice. Eventually, this is all going to click and you won't even think twice when you use them. In our next episode, we're going to be talking about inputs, which are pretty simple, but they're very useful. Thank you for watching, and please like, comment, share, and subscribe.